Alrighty, I mean, you can look at different wind fields and just play around with trying to identify regions that produce convergence or a divergence of the Ekman transport. And this is done here with this sketch. This is something that Matt Tomczyk, who was the previous professor in oceanography here at Flinders, and sadly Matt passed away last year. Okay, but this is from his textbook, and shows different situations. So you see some situation. I think this is the Eastern Atlantic Ocean, and all these arrows shows you the wind field. Okay, it's the wind stress represented as in terms of arrows. The longer an arrow, the stronger is the wind, and you can also see directly the wind direction. Okay, so now in order to understand what happens in the ocean is you just have to imagine Ekman transports. Okay, north of the equator, here's the equator. Okay, here's the equator. North of the equator, to the right with respect to the wind direction, south of the equator to the left. What you immediately can see along the equator is a situation where there is water moved away from the equator. The Ekman transport, sometimes also called Ekman drift, is to the north of the equator, to the south of the equator. Okay, and you can see other, and I just urge you to play around with it. Okay, if you have access to a wind field, look at different regions and imagine what happens. Okay.